Hey Dons, this is Mr. Sipple, and I'm here with you for the Geometry Unit 3 test retake. And the way that this is going to be structured is that I'm going to be going through each one of the questions that was on the test itself, and then you'll have a retake to do on Edge Elastic. If you are needing just to get a refresher or need help with just a few of the problems, then the timestamp is included for each question, so you can fast forward the video if you don't need to watch this whole thing. However, if you're feeling kind of lost and you're not really quite sure how to do much of what's here, then I would tell you that you would watch the whole video. But either way, you don't watch the video entirely and then do the test. The idea is that you watch the video for a question and then you try it yourself. And so you kind of go back and forth between watch the video, try a question, watch the video, try a question. All right, so we'll go ahead and get started. So the first section here deals with angle relationships that come up when we have parallel lines. And so we know that these lines are parallel. See the little arrow on there? That indicates that these lines are parallel. And when we have parallel lines, and then you have a third line that crosses, this third line here that crosses here, we call that a transversal. And the idea with the transversal is that it's a line that cuts across two parallel lines. Well, and then when that happens, there's some angle relationships that come up. And so that's what the questions 2, 3, and 4 are going to be asking you about. So the first relationship that we're going to see here, and before I tell you what it is, I'm just going to kind of experiment with it myself. So I'm going to come over and take a look at this. And on the test itself, you'll see a link that says try it yourself. Click here. So each one of these little virtual manipulatives that I'm using, you can use that yourself as well. So what we notice here is that when you have a transversal that cuts across, and we'll try to match up the problem, this example here. So they say that this angle here in the bottom right is 146. So notice what happens though is that these angles are the same. That transversal kind of makes 4 quadrants, cuts it in 4. And so notice that those angles are the same, and then those angles are the same. And let's say I try to move this out to 146. As you could probably imagine, you can already see that it doesn't matter how I change this, those two angles would be congruent. So that if this angle is 146, this angle would also be 146. So those angles match. And so the word that we use for the fact that they match is that we call them corresponding angles. So corresponding angles are angles that match up with each other. So if this is 146, then this also would be 146 as well. And that, again, that only works if the lines are parallel. Notice what happens when I make these not parallel. Then those two angles are not the same. And then when I move those around, I can see that they're not the same. So this only works if these two lines are parallel. And then if they are, then we can show that those are the same. Actually, let me get that back to parallel. There we go, back to parallel. All right, so that's the first relationship, is the corresponding angle relationship. Also, if you have patty paper, what you can do is you can line up on your patty paper. If you kind of trace this angle right here, and then you trace that with your patty paper and you slide it down, what you'll notice is that those two overlap. They're exactly the same angles. And so because they match up, we call those corresponding angles. Next angle relationship we're going to look at is if we have those same two parallel lines, but notice now what happens is that these are on different sides. Well, we call those alternate interior angles, and we'll see in a second why that's the case. So let me show you the case of the alternate interior angles. And the example they have this bottom angle equal to 33 degrees. So let me match that up. They have this angle down here equal to 33. And maybe just need to move this a little bit. There we go. So notice what happens. So I made this angle 33. All I did is I just matched it up with the diagram right there. And then what I'm trying to figure out is that what would this angle 1 be equal to? Well, notice what happens is that it's the same thing. Now, again, this is only true if they're parallel. Notice if they're not parallel, the lines aren't parallel, then they're not equal to each other. But if they are, then those are equal to each other. They're on opposite sides of the transversal. So this line right here, they're on opposite sides. So we call those alternate interior angles. Why do we call them interior? Well, the two lines here, the two parallel lines, if you think of that as the sandwich, it's on the inside of the sandwich, right? So anything outside of those two parallel lines, we would call exterior. but anything that's on the interior, in between these two lines right there, so we would say that that would be interior. And then they're on opposite sides, right? One's on that side and one's on that side. So since they're on opposite sides, we call them alternate interior angles. And that word alternate just refers that they're on opposite sides. They're not on the same side. They're on opposite sides. And so what we know is that alternate interior angles, their angles are congruent. So if this is 33, that would be equal to 33. And then the last angle relationship we have for parallel lines, the last one we talked about is they were on opposite sides. Notice what happens here. These are on the same side. So, and they're on the interior, right? They're in between those two parallel lines. They're on the interior. So when they're on the interior and they're on the same side of the transversal, then what we call those is we call them same side interior angles. Now, what's the relationship? Well, let's take a look at our manipulative and see if we can figure out what the relationship is here. Is in this kind of bottom left corner over here. So we'll get that to match up. And notice what's happening, by the way, even, so we'll move this around to that corner. And then let's move this to, we'll manipulate this so we get a 29-degree angle. So there's our 29-degree angle. Obviously, those are not the same angles. These angles are not congruent. This angle down here is much larger. That angle up there is much smaller. So they're clearly not the same angles. And then what we notice is that they do add up to 180. And notice what happens is that if I move this around, notice that it still adds up to 180. The idea where this is coming from is that let's say we made it 90-degree angles, with like a box, like a rectangle. So the edge of this box or the edge of this rectangle would add up to 180, right? 90 plus 90. Well, think about what happens when I do this. It's no longer a rectangle. Now I'm making a parallelogram. But those two corners are still going to add up to 180, whether they are straight like that or if they're at an angle. And if they go way out here to 29 degrees, which we're doing for this one, that just means that this ends up being a much larger angle, but they're still going to add up to 180. So the relationship that we see with this one is that these angles are not congruent. Obviously, they don't look like they're the same angles, but they are supplementary. They add up to 180. So what I would do with this one is I would say 180 minus 29. And I already know the answer is 151, but we'll just check this, double check this. Try not to do too much mental math on this because it's really easy to make a little mistake. So what I would encourage you to do here is use your calculator. Even if it's for a calculation that you think you could do in your head, just put it in the calculator to be safe. So 180 minus 29, and then so we get 151. And so our answer there would be 151. All right, so go ahead and you would stop the video here and try questions number 2 through 4 on the practice test. The next section is going to cover questions 5 through 7 on the test retake. I said practice test a second ago. I meant test retake. So the next section is going to cover angle relationships that occur when lines cross. In this case, we're looking at two lines that cross here. So lines that are not parallel. What do you notice there? So you notice there's a little box, and we know that this little box here means that the angles, that this is a right angle, right? So when you see that little box, then we know that that's a 90-degree angle. Well, so that the two things are going to add up to 90. So let me just kind of take a look at this. One of the angles is 48. So what would the other angle be? Well, notice what happens. It doesn't matter how I move this thing. They add up to 90 degrees either way. So if this one angle is equal to 48, then that means the other angle would be equal to 42. If I was doing this with the calculator, and by the way, we call these angles complementary. So angles that add up to 90, so if it adds up to 90, then we call those angles complementary. If I was doing that on a calculator, I just would do 90 minus 48. And again, use your calculator to make sure that you don't make any mistakes. So 90 minus 48, and we end up getting 42. So our answer here for this one would be 42 degrees. Number 6 gives us another relationship here that we're seeing. I don't see a little box there, so I know that we're not talking about something that adds up to 90 degrees. I do think of this, though, if I made this a circle, and what I just drew is not a perfect circle, but just use your imagination. And then if I took half of a circle, let's think about what half of a circle is, right? If you cut a circle in half, we know that a whole circle is 360 degrees. So what would half of a circle be? Well, half of a whole circle, so a circle is 360 degrees. So what if I took half of that circle? Well, half of a circle, right? So a half circle is going to be half of 360, which is 180. So that's one way for us to see that these two angles are going to add up to 180 degrees. Complementary means that they sum to 90. Supplementary, there's two words that we're actually going to use here. You'll see linear pair. We also use the word supplementary. And what that means is that they sum to 180. So our answer here would be that this is an example of a linear pair. And I could see that over here is that if I took my one angle is 24. So let me make this angle 24. And then what would my other angle be? My other angle would be 156. So notice what happens here is that those two numbers, no matter how you move this around, because it makes half of a circle, those two numbers are going to add up to 180. So I'll put that back where it was, which was 24. Yep, 24. If I was doing that with a calculator, I just would do 180 minus 24. And then on the calculator, I already kind of know what the answer is going to be, but we're just going to double check it. 180 minus 24, and we get 156. 156 degrees. 156 degrees. All right, so one more relationship we'll look at when we have lines that are crossing here. Let's look at this one. So this says it's 152. And we just said that half of a circle is 180. So if half of the circle, if this would be 180, then couldn't I figure out what this angle would be, right? 180 minus 152. So let's do it. Let's say I said 180 minus 152. So that means that this angle would be 28. Oh, but isn't this then another half circle, right? So what if I looked at the half circle this way? What if I looked at it from here to here? Well, this would also be equal to 180 degrees. So if I wanted to know what this angle is, then I just do 180 minus 28, and then that'll tell me what this angle would be, angle 7. So let me do 180 minus 28, 180 minus 28, and I get 152. Oh, wait, 152, that sounds familiar, because the angle that's right across from it is also equal to 152, right? 152, 152. So the relationship here, I kind of went about it the long way to prove it, but the shortcut is just to see that angles that are across from each other, which we call vertical angles, these are across from each other, So angles that are across from each other, and again, we have the definition up here as well. We call those vertical lines. And again, I can prove that if I go over to this one. And notice what happens here. It doesn't matter how I kind of move this. And it kind of looks like an X, right? That's one way to spot a vertical angle is it looks like an X. If you're a Star Wars fan, kind of looks like a TIE fighter. But notice what happens is that angles that are across from each other, they're congruent. They're equal to each other, no matter how I turn this, right? So no matter how I turn this, because the whole thing adds up to 360, right? The whole thing makes a circle. So it doesn't matter how I turn that. Those angles across from each other are going to be congruent. All right, so that finishes up numbers 5 through 7. So stop the video here and do numbers 5 through 7 on the retake. Number 8, this next section of the video is going to cover numbers 8 through 11 because these questions involve angles inside of a triangle. So previously we were looking at what happens when angles, if you have parallel lines and then you have a line that crosses, or if you have lines crossing each other in the case of vertical angles. Here we're looking at the inside of a triangle. Well, we know that the triangle sum theorem says that everything in a triangle adds up to 180. So that's just by definition, that's our triangle sum theorem. And then we want to be able to use that to solve for angle number 5. Just to prove that real quick, or just to kind of give you a visual on that, And again, all of these, all the things here that I'm, when I go here, uh, oh, disappeared. So notice what happens here. No matter how I manipulate this triangle, take a look at that number in the top right corner. No matter how I manipulate this triangle, maybe I make this a right triangle. Maybe I make this a 90-degree angle. Everything still adds up to 180 degrees. So it doesn't matter how I manipulate this or how I move this around. It doesn't matter what kind of triangle I make this. Notice that everything adds up to 180. When we're looking at this, we don't know right away what angle 5 is equal to, but we do know that everything is going to add up to 180. So I do know that if I took 37 degrees plus 98 degrees plus whatever angle 5 is, that's all going to add up to 180. So I'm going to take that. Let's just use a calculator on this. I kind of made an equation out of it. You don't even really need to do that. Just take 180 and subtract the other two numbers, 37 and 98. So minus 37 and then minus 98, and that would equal 45. So that means that this other angle inside the triangle is equal to 45 degrees. Next relationship is, what if we have an equilateral triangle? Well, so notice what these lines mean is that these lines mean that all of the sides of the triangle are equal to each other. Well, there's pretty easy relationship here with this one, because let's say I take an equilateral triangle. Notice what happens here. No matter how large or small, I'm changing the sides of this triangle, right? Like I'm making it smaller, I'm making it larger. But notice what's happening with the angles. It doesn't matter what I do to this triangle, the angles are fixed at 60 degrees apiece. We know that because the total of the triangle is 180. And then so if I say 180 divided, and that means that each one of these angles are also going to be the same. So 180 divided by 3 is going to be 60 degrees. So my angle measure there would be 60 degrees. And how do I know that? Well, this is an equilateral triangle. So I would call that the property of an equilateral triangle. Last relationship here is that if we took, actually we got two more there. Okay, good. So next relationship, notice that this one only has marks on two of the sides. It doesn't have a mark on this side as well. So what we call that is we call that an isosceles triangle. That's when two of the sides are congruent. What we also see is that if those two sides are congruent, those base angles are congruent. So let me kind of show that to you. So if we went over to an isosceles triangle, and they've got, in the problem here, they've got one of the base angles is 46. It was actually already set to 47. Notice what happens when I change that to 46. This other angle is also 46. But let's say I just kind of click and drag it. Notice that no matter how I change this triangle, these two base angles stay exactly the same. And that's what we have when you have a isosceles triangle. If the sides are the same, the base angles are the same. So then for this one, if this is 46, then this angle right there would also be 46 degrees. They're going to match. They're congruent. So, and this is the case of an isosceles triangle, and our angle measurement there would be 46 degrees. All right, so last relationship we're going to look at here with triangles is, what if you don't know, well, you don't know two things here. You don't know an angle that's on the inside and then this angle right here. Well, we know a triangle adds up to 180. So if I want to find out what this missing angle is, then I'm just going to do 180 minus 38 and 23. And so let's figure out what that is. We'll use our calculator for that. So 180 minus 38 minus 23. And so we get 119. So this angle here is 119 degrees. So 119. And then we know that a linear pair, if they're on the same line, we know that those add up to 180, right? And we looked at the linear pair in one of the previous questions. So what that means is that if one of these is equal to 119, let me set this equal to 119, then what would the other angle be equal to? Well, if this is 119, the other angle would be 61. So what that means is that this would be 61. And again, I could show that because if I did 180 minus 119, and then I put that in the calculator, let's just double check that. Good idea to always double check your numbers in the calculator because we don't want to get something wrong because we made a silly little kind of arithmetic mistake. Minus 119, which is 61 degrees. So what that means is that this one is 61 degrees. Now that's kind of the long way around it. You might be noticing a relationship here, by the way, 38 and 23. Let me show you something with this. Let's say that I made, I'm just going to try to copy the diagram here. So I'm just going to copy the diagram that they've got. They've got 38 and 23. Let me move this over to 38. 38 might be a little tricky if you're doing this with a mouse. And then this one, I want this angle to be 23, and then we're just going to have to kind of play with it just a little bit. Might be hard to get this exact. I had it there a second ago. There we go. Whew, okay. So notice what happens here. 38 plus 23 is 61. Oh, okay. So here's a shortcut. I mean, we kind of went about it the long way. We figured out what this angle was, and then we knew that they were supplementary. So we subtracted it from 180 to get the 61. But here's a shortcut, and we call this the exterior angle theorem. And basically what it means is that if you're missing the angle on the inside, if you take the two that you do have, 38 plus 23, and you add them together, it'll give you the angle that's on the outside. So there's two ways you can look at it. There's kind of the shortcut, which is this, and then there's kind of the other way of just figuring out the angle on the inside and then using your linear pair relationship. All right, so go ahead and pause the video here and do numbers 8 through 11 on the retake. Number 12 has us looking at back to a parallel lines. We know these lines are parallel and we have this transversal. If I'm just eyeballing this relationship, again, this angle looks very similar to that angle right there. And so if we recall, this is the example of our alternate interior angles. And what that says is that it says that those angles are going to be congruent to each other. So remember, if they're on the alternate side of the transversal, and I'll get this. We don't actually know what the angle is because we actually have to solve for it. But just to get the visual, remember, if they're on the opposite sides of the transversal, then they're the same thing. And again, it doesn't matter how I move that around. We see that those are congruent. Well, so if they're congruent, what I'm going to do is I'm just going to set them equal to each other. So I'm going to say 8x plus 24 is equal to 10x minus 2, since they're the same angle. And then I just need to solve for x. So remember, if you have x's on different sides, you just want to move all your x's together to the same side. I could have moved the 8 to the 10. Just as a preference, I like to move things to the left, but either way works. The first part of this is actually so the first blank here, by the way, is just setting up the equation. 8x plus 24 equals 10x minus 2. So the answer to part A is just the equation of how to set it up. And then to part B is where we're actually going to solve it. So this equals -2. And then this is where it's just algebra 1 flashback here. We're just solving the equation. And then so our answer here would be x equals 13. And this particular question, we're not required to go back in and solve for those angles. Though we could plug that back in and we would see that those two angles would match, right? If we plugged in 13, then we get 130 minus 2, which is 128. And then if I plugged 13 in there, I would get the same thing as well. All right, so pause the video here and try number 12 on the retake. Number 13 is another question where we're using our angle relationships that we've already looked at. So we know that if everything in a triangle adds up to 180. So if I don't know what these individual angles are, that's okay, because I'm just going to add them all up and add it equal to 180. So I'm going to take, the first one is just, what's my equation? How am I going to set it up? So I'm going to take 63 plus 20x minus 2 plus 12x plus 23 and set that equal to 180. So for part A, that would be my answer right there. It's just how would I set it up? And so how I would set it up would be that way. Now you could combine some like terms here, combine your x's and numbers, and we're going to do that in a second. But for the first part, you could write your answer just like that, which is how do you set it up? Now that we've set it up, let's actually solve it. So 63, I'm just going to write this out again real quick. 2x, 20x minus 2 plus 12x plus 23 equals 180. So it looks messy. We just got to clean this stuff up. Let's combine our x's. So I've got 20 x's and I've got 12 x's. So that would make a total of 32 x's. And then let's combine my numbers. I've got 63, and then I've got minus 2, which would be 61, and then plus 23. And then so 61 plus 23 would be 84. I just want to make sure I did that correctly, so I'm just going to double check with my calculator. So 63, because again, we don't want to make a silly mistake. We don't want to lose points this way. 63 minus 2, which is 61, and then plus 23, which is 84. So I'm good, but we just wanted to double check that. And that's going to be equal to 180. So now at this point, it's just an algebra 1 equation, just solving for x. So 32x equals, we'll do 180 minus 84. 180 minus 84. And so we get 96. And then we'll divide by 32. And so we're going to get x equals 3. But again, we'll double check that. I'm sorry, it was 96 divided by 32. I was thinking of the answer, which is 3. So x equals 3. Pause the video here. Try number 13 on the retake. Number 14 is similar to the last question. The difference is on this one, we're given that the triangle is isosceles. So if we know that it's isosceles, then we know, and we've already looked at the situation of the isosceles triangle. With an isosceles triangle, it doesn't matter how I change this, these base angles are going to be the same. So we actually don't know. They don't tell us what the side lengths are because we're not actually looking for that. We're looking for the angles. But so what we do know is that whatever the bottom right is, the bottom left would be the same. So if the bottom right in this case is 2x, because again, we know that these angles, and we'll kind of mark it on our toolkit notes here, those angles are congruent. So if this is 2x, then that means that's also 2x. And then so if we go to set that up, then we've got 6x plus 2x plus 2x equals, right, because they're the same. And then we're still using our triangle sum theorem, which says everything in a triangle adds up to 180. So then we're going to sum that to 180. So the first part is just setting up the equation for part A. So that would be your setup. And then we'll go ahead and solve this. This one's a little bit cleaner than the last one because we just have some x's we have to combine. So I've got a 6x and a 2x and a 2x. So if I put all that together, I've got 10x. And then divide both sides by 10. And x is going to be equal to 18. And just because I don't trust myself, 180 divided by 10 is 18. So our answer there would be 18. Pause here. Go ahead and try number 14 on the retake. Number 15, the last couple problems here deal with relationships of a right triangle. And so the first part of this is just a little bit of vocabulary. And the vocabulary here is in your toolkit. So the two sides of the triangle, we call those the legs. So this would be a leg, and this would be a leg. So AB would be a leg, and then BC would be a leg. And then the third side, we call this the hypotenuse. This would be the hypotenuse. How do you know which one's the hypotenuse? Well, it's the side opposite the right angle. So wherever the right angle is, if you look out across from that, that would be your hypotenuse. So even if the triangle is turned, because sometimes these triangles get rotated and turned different directions, and then you might not be sure, which side would be. Well, that's a pretty sad looking right triangle, isn't it? You may not be sure which side is the. I should use the draw tool for this. Hold on. Apparently, I can't draw a straight line. How about that? That's a little better. So let's say the triangle's rotated and you're not sure which one's the right angle, or I'm sorry, the hypotenuse. Well, just start with the right angle, and then wherever that is, it almost kind of points at the hypotenuse. So that would be the hypotenuse. And then the other two sides, once you identify the hypotenuse, the other two sides are just the legs. So we would say those two would be the legs. Pause here, try number 15. Number 16 is you putting what we just said together, because we have to identify which side's the leg, which side's the hypotenuse. So again, side opposite the right angle, that's always the hypotenuse. So I know that's the hypotenuse. I'm just abbreviating it HYP. And then, so that means that the other two sides would be the leg. So this would be a leg, and then this would be a leg. Well, there's a relationship that happens, which is that if we have a right triangle, what ends up happening, so there are more than just a handful of proofs to the Pythagorean theorem, but here's one visual for you to consider. If we had a right triangle and then we made a square off of each one of those sides, when we say a squared plus b squared equals c squared, what that means is that if we made a square out of a and then we made a square out of b, and then we took those two together, what we would find is that they would fit inside the square that's formed by side C. So notice that the area, so if we're thinking of this in terms of area, all of these would fit inside of this third square. So when we say a squared plus b squared equals c squared, we're saying that if you took the area of, that's a little off, but there you go, you got the idea. If we took the area formed by a square from A, a square from B, that it would fit inside of this third square, which is C. So what we're going to do then is we're going to take A and B. A and B represent the legs. So I would say 34 squared. 34 squared, so 34 squared plus 14 squared. And then again, A and B, this is a leg. So that's these two are legs, that's a leg, that's a leg. And then the C is the hypotenuse. So it's important that we make sure we label the legs and hypotenuses correctly. I don't know what the hypotenuse is, so we'll just call that x squared. You could also use C. So you could use C squared, you could use x squared. And then this will end up being, for part A, that's our equation. Now, for part B, what we want to do is we want to solve it, and we're going to round our answer to 3 decimal places. So let's go ahead and solve this. So I'm going to rewrite this: 34 squared plus 14 squared equals x squared. Absolutely use your calculator here. So we're going to do 34 squared, which would be 1,156, plus 14 squared, which would be 196. And then let's combine those two. So 1,156 plus 196, and we get 1,352. And then, as with any equation, we're trying to solve for x, and then it's like, well, how do I get x by itself if there's a little 2 up there? Well, what we do is the opposite. We always do the opposite of something, right? The opposite of a plus is a minus. It's always the opposite operation. So the opposite of squaring something is to take the square root of it. Because what happens is that when you take the square root of something that's already squared, these two things kind of cancel each other out, and then you're left with just x. Well, what we do to one side, we have to do the other side. So I'd have to take the square root of that side. So, and again, we're going to the calculator for this. So we're going to do the square root of 1352. And I get 36.769, blah, blah, blah. Now, what we want to do is we want to round this to 3 decimal places. So I'm actually going to write this to the 4th decimal place, 7695. 7695. And then, but what we're doing is we're cutting it off after the 3rd decimal place. So we're going to cut it off right here. So when you establish your cutoff, you look at the number past the cutoff, and if that's 5 or more, you round up. If it's less than 5, you would keep it the same. So what happens is that this one is, since it's 5, that means we'd round that up to a 10, which means we then it ends up kind of triggering a change in the other one. So this actually would be 36.77. And again, that's because the 5 rounded that up to a 10. And then once you hit 10, you got to round up the next number, right? Which would be 6 to 7. So our answer there would be 36.77. And I know it says 3 decimal places, so this would be, you could put a 0 or you could just leave the 0 off. I would probably just leave the 0 off, so 36.77. All right, try number 16 on the retake. Number 17 deals with what's called the triangle inequality theorem. Basically, what it says is that a triangle, if the lengths of a triangle have to be right, because either the triangle could be too short and then they don't reach each other, or it's too long and you got one side that's sticking off to the other one. So the relationship is that to find what we say is the range of the third side, we're going to subtract to find the smallest it can be, we're going to subtract the two sides. And then to find the biggest it can be, we're going to add the two sides. So for example that's here is that if you have 18 and 24, we're going to add 18 and 24 to get 42. To find how small it would be, we're going to subtract 24 and 18 to get 6. Our numbers in this question that they want us to look at are 14 and 26. So then what I'm going to do is I'm going to set this up. And this notation just means that x is anywhere in between this number, the smallest number, and the biggest number. Well, let me add these two numbers together. So I'm going to say 14 plus 26. And then, so with that, I would get 40. And then on the smaller side, I'm going to subtract the two. So I'm going to say 26 minus 14. And if I subtract those two, then I get 12. So my answer for this one, the smallest the triangle could be, would be 12. And then the biggest the triangle could be would be 40. Because if it's smaller than 12, these two sides don't meet and it doesn't make a triangle. If it's bigger than 40, you have one side that kind of continues on, and then we have a triangle that would look like, anything bigger than 40 would be a triangle that kind of looks like this, where you have this part sticking out. Or if it's smaller than 12, you have a triangle that looks like this, where the two sides don't meet. So to make them actually be a triangle, the smallest it could be would be 12. The biggest it could be would be 40. And then, so could it be, notice that it has to be less than 40. So could the third side be 40? No. So the third side could not be 40. Notice that we don't have the or equal to sign underneath there. So it has to be less than 40. So it can't be 40. 31, yeah, that's in between 12 and 40. So that would work. 12.5, that's bigger than 12. That would work. 59, nope, that's bigger than 40. It would need to be less than 40. So that would not work. So you're looking at these numbers and then comparing there. That's number 17. So pause here and give that a try on the retake. Number 18, this will be the last video portion. What we'll talk about here, we'll cover problems 18, 19, and 20 on the retake. Go back to that visual I showed you on the previous problem with the Pythagorean theorem. This idea that if it is a right triangle, then these two squares would fit into that one. But what happens sometimes, and here's just a visual at the top here, is that what if the triangle, those two smaller triangles don't fit into the larger one, either because the larger one is too large or the larger one is too small? Well, that will dictate to us what type of triangle we have. You'll notice that if the biggest side is less than the sum of the other two, then it makes an acute triangle. And acute means that all of these angles that are on the inside are going to be less than 90, right? Those are all less than 90. If they do fit, right, if the two smaller do fit into the larger, then it is going to be a right triangle, right? And that means that that would be a right triangle right here, 90 degrees. But what happens if the bigger side is bigger than the sum of, or is larger than the sum of the other two, then we end up with an obtuse triangle. And an obtuse means you have an angle here that's larger than 90 degrees, right? So this would be less than 90 degrees. This is equal to 90. And then this one would be greater than 90 degrees. All right, so how do we, so how do we end up kind of determining that? We're just going to take the two smaller sides and see if it fits into the larger. You'll notice that all of these, there's two ways we could write Pythagorean theorem. We could write it as a squared plus b squared equals c squared. Or we can also flip it around. We could say c squared equals a squared plus b squared. So since we're comparing the larger square to the two smaller, we're going to write the c squared part first and then compare it to the sum of the other two. So I'm going to take the largest number, which in this case is 29, and that's going to be my c squared. Now, I don't know if it's equals, less than, or greater than. So I'm just going to put a question mark because I don't know if it's equal, less than, or greater than. And then I'm going to take the two smaller sides. So 17 squared plus 13 squared. And then we're just going to see if they are equal to each other, or they're less than or greater than. So again, use your calculator on this one. So we'll do 29 squared, and I get 841. And then 17 squared, which is 289. And then 13 squared, which is going to be 169. Now, I just need to add these two together. Again, this is question mark. I don't know if these are equal to each other or not, or if one's less than or if one's greater than. So let's do 841. And then I just need to add these other two ones. So 169 plus 289, and that equals 458. So 841 is not equal to 458. 841 is greater than 458. So what that means is that means that this one is going to be obtuse because this large square is larger than the sum of the two smaller squares. So what we would say here is this would be obtuse. This is obtuse. And then when it says here, write the final inequality, what we're going to write is how we knew that it was obtuse, which is this right here. So I just would write 841 is greater than 458. So that's the example of obtuse. And then in the next two problems, we'll see an example of either an acute or a right. So let's do the same thing. I'm going to just take the smaller sides, and I'm going to start with the big side, right, which is the 15. So I'm going to start with the 15 squared. And then I'm going to say 10 squared plus 12 squared. And again, I don't know, I'm putting a question mark here because I don't know if they're equal, less than, or if they're greater than. But let's just put it in the calculator and we'll get the numbers for it. So 15 squared would be 225. So I've got 225. 10 squared is 100. 12 squared is 144. So if we add those together, then we get 244. And then 225, it was a mystery. We weren't sure if they were equal or not. Now we know that 225 is less than 244. So if the largest square is smaller than the sum of the other two, it's this situation right here, where this is smaller. These two are bigger than, these two put together are bigger than that square. So we would say that this would be acute. And then our inequality would be what we said right here, which is that 225 is less than 244. Well, by process of elimination, our last question here is going to be right, but let's prove that it. So we're going to start with, remember, we're always starting with C, which is the longest side. So the longest side here, and maybe it's not a bad idea if we label it, if you want to label this as A, B, and C. So let's start with the longest side, which would be 45. So I've got 45 squared, and again, I don't know if it's equal to, less than, or greater than. And so we'll do 45 squared, and then we've got 27 squared plus 36 squared. Obviously, we're going to use a calculator here. We're dealing with some large numbers. So we'll do 45 squared, which we get 2,025. 27 squared, which we get 729, and then 36 squared, which we get 1296. And then we're going to add these two together. So 1296 plus 729. And then we get 2025, which is the same. That's what we thought was going to happen. So we weren't sure, but then we got down to the bottom here. Those two are equal to each other. So if what that means is that this is the example of the right triangle. So that means that the two smaller triangles, two smaller squares will fit exactly into the larger square. So this would be a right triangle. And then our quality statement here would be 2025 equals 2025. All right, we've reached the end of the video here, or the end of the review. So what you would do now is go ahead and stop the video and do 18, 19, and 20 on the retake. And again, if you need to go back and rewind or look at any of the other questions, you've got the timestamps. Go back to question number 1. It's got the timestamps. And then you can scroll around to see the different videos. Hopefully this was helpful. And then hopefully we're able to get you to a place on the retake where we get a better score. But you get a better score because now hopefully you understand a little bit better. All right. Stay safe. Take care. Bye-bye.